Mind uploading. Sounds like something straight out of a movie, right? But how close are we really?
So could you just back up your brain and live forever as a digital you? That's the dream.
Basically, the whole idea is to perfectly copy your mind and run it on a computer. Think about it. Digital immortality. Space travel is pure data. It's about breaking free from our bodies. Okay, but here's the wild part. The building blocks for this? They're already being built. Right now. Get this. Scientists have actually transferred a memory. Not between people, but between simple sea snails.
So how'd they do it? They took RNA from a trained snail and put it in an untrained one.
And the result was just crazy. The new snail acted exactly like it had the original's memory. This hints that memory isn't just in the wiring, and restoring it in humans, yeah, that's happening too. Scientists built a device to help people form new memories, and they've already tested it on patients. It records brain signals, predicts the right output, then stimulates the brain to match it, bypassing damage. And it worked. You can see here, patient's memory recall jumped by a huge amount. Incredible stuff. Okay, so the basic science is there, but the engineering challenge? That's a whole different, massive problem. 5 exabytes. That's how much data it might take just to map one single human brain. And the power to run that map? It's just astronomical, way beyond what our supercomputers can do today. Plus, our best mapping technique right now is, well, destructive. It involves slicing the brain into millions of layers. So this brings us to the biggest question of all. If you upload, is that still you? Or did you die? It's the core debate. Are you just a pattern of information? Or is your physical brain essential? A lot of thinkers say uploading just makes a copy. A perfect clone, sure, but the original you is gone. But one theory says your identity could just branch, and you'd have 2 authentic yous at once. So, putting philosophy aside for a sec, what's the actual timeline for this? When could it happen? Well, experts see it happening in stages. First, mapping smaller animals, then developing restorative tech for us. And this isn't just theory anymore. It's sparked a real movement for neuro rights to legally protect our minds. Which leaves us with this final thought. If your mind can be copied, what does it even mean to be you? Today, we're diving into one of the biggest ideas out there, something straight out of science fiction but getting closer to science fact. The wild possibility of cheating death by, uploading your mind to a computer. I mean, really think about that for a second. What if your mind could outlive your body? It's a question that kind of forces you to ask, what am I really? Is your consciousness everything that makes you you stuck in the squishy hardware of your brain? Or could it just exist as pure information, totally free from all our biological limits? That right there is the dream of mind upload. So the fancy term for this is whole brain emulation. The basic idea is to create a perfect digital copy of how your brain processes information. And we're not talking about just a recording like a video. We're talking about a simulation so incredibly accurate that it would, theoretically, wake up with all your memories, your personality, and your consciousness completely intact. And if we could pull this off, the potential benefits are just staggering. For starters, you could have a kind of digital immortality, right? You'd have backups to protect you from accidents or disease. We could send uploaded astronauts on 1,000-year trips to other stars without worrying about life support. We could even, maybe, edit our own minds to be smarter or happier. And get this, because digital circuits are so much faster than our neurons, a simulated mind could experience what feels like centuries of thought in a single day. Wild. Okay, I know this all sounds like pure fantasy, but the foundational science is already happening, and some of the results are genuinely shocking. This whole concept is slowly moving out of the realm of sci-fi and into reality. So check this out. In a pretty landmark experiment, scientists trained these little sea slugs to have a stronger defensive reflex. Then, they took RNA, that's the molecule that carries instructions from our DNA, out of the trained slugs and injected it into totally untrained slugs. And result? The slugs that got the injection started acting like they had been trained. They essentially got a memory transfer. And we're not talking about a small change here. The reflex in the recipient slugs was 40 to 50 times stronger than in the slugs that didn't get the RNA. What this suggests is amazing. Memory might not just be in the connections between our brain cells. It might actually be stored in the molecules inside our neurons, like a biological code that can be copied and pasted. And what's even crazier is that we're seeing this kind of thing in humans, too. Scientists actually developed a cognitive prosthesis for the hippocampus. That's the memory center of the brain. They figured out how to record the specific electrical patterns your brain makes when it forms a memory, and then they can play those patterns back. And by doing that, they've boosted memory recall by up to 54%. So in a very real way, we are already starting to hack the memory code.
Okay, but let's take a breath. There is a huge, huge difference between boosting one little memory circuit and capturing an entire human mind. The sheer scale of the brain presents one of the biggest engineering challenges we have ever faced. So, just to map out the wiring diagram of a single human brain, what they call the connectome is estimated to take up to 5 exabytes of data. To give you some perspective, that's roughly the same amount of data as all the words ever spoken by all human beings, ever. It is a truly colossal amount of information.
And it's not just about storage. You need the computer power to actually run the simulation. A simple version that just captures when neurons fire would already need a massive supercomputer. But what about simulating all that detailed molecular stuff that the sea slug experiment showed us is so important for memory? Well, that would require computers that are orders of magnitude more powerful than anything we have today. We're not even close.
So, what's a realistic timeline here? Well, researchers think we might have a decent map of an insect brain sometime in the 2030s. The first, probably very crude attempts at a human brain simulation might happen in the 2040s or 50s. But a high-quality live backup of a human mind, that's probably a post-2060 project, and honestly, maybe much, much later. This is a century-long kind of goal. But let's just imagine for a second that we solve all of that. We've got the scanner, we've got the storage, we've got the supercomputer. Then we run into an even bigger question, one that technology just can't answer. Would that digital mind actually be you? The philosopher Susan Schneider puts it pretty bluntly. Her argument is that when you create that perfect digital replica, you're not transferring your consciousness. You're just making a copy, a digital twin that thinks it's you, that has all your memories. But the original you, that you simply dies. And even if you try a different method, like a gradual replacement, swapping out your neurons one by one with a tiny silicon substitute, you just run headfirst into that classic philosophy problem, the ship of Theseus paradox. At what point does the original you stop existing? After the first neuron is replaced? The billionth? No matter how you do it, that fundamental problem of who you are doesn't go away. It really all comes down to this. Are you just the pattern of your information, something that can be copied and pasted like a computer file? Or is your consciousness, yourself, tied to the actual physical, biological stuff that makes up your brain? There is no easy answer to that one. Now, you might be thinking this is all a debate for the distant future, but it's not. The technologies we're building right now on the path to mind uploading are already forcing us to think about new laws and ethics to protect the one place that's always been private, our own minds. And this has led to this whole new concept of neurorights. You can think of them as basic human rights for your brain. Things like mental privacy, so nobody can read your thoughts without permission. The right to personal identity, so no one can alter your sense of self. The right to free will, to protect you from being manipulated. And it also gets into really important social issues, like making sure these technologies are available to everyone fairly and that we're not discriminated against based on our brain data. And this is not theoretical. It's really happening. In 2021, Chile actually became the first country in the entire world to change its constitution to protect the mental integrity of its citizens. The age of neurorights is already here. So that brings us right back to the ultimate question. If the tech was perfected tomorrow, if someone offered you a shot at digital immortality, knowing all the scientific hurdles and all the deep philosophical questions, would you say yes? Would you upload? It's a decision that really gets to the very core of who and what we think we are.